Hello, everyone. We'll just give it a couple more minutes to let some more people join in, and then we'll get started. Okay, I think now's a good time to get started. Welcome everyone to today's presentation on the introduction to the GS9000 and GPR scanning made easy. Um, the presentation is going to be run by my colleague Gorka Santamaria. He's the Senior Product Manager for Geomatics at Green Eagle, and myself, David Fowkes, who's the Director of Sales for Subsurface here as well. So just before we get started, I'm just going to start with a poll question, just on how many of you have used multi-channel systems in the past. So if you guys can answer that. The other thing as well to note is that we are going to run a live Q&A at the end of this session as well. So at any point through the presentation, if you have any questions, there's a link at the bottom there. This is Q&A. Please write your question in there, and me and Gorka will answer as many of them as we can. Okay, Gorka, I'll hand over to you.
Perfect. Yeah, hello, good afternoon to everybody, and welcome to this session, introductory session to the GS9000, or how we like to say GPR scanning made easy. We will present in this session this new innovation, this new product, and put it into context of ground penetrating radar and methodologies and applications. But let me first start with a little bit of a high-level introduction. So essentially, first of all, in which context do we utilize GPR or ground penetrating radar today? Essentially, as a means of getting construction projects be more efficient. However, the way they mapping of underground elements is probably not as efficient as it would need to be in order to achieve this goal. We really need a more efficient mapping procedures than just sending out big crews with different technologies and different devices to do the same step once and again in a very fragmented way, and then send everything to the office so that the information gets consolidated as a separate step. There's ways to be way more efficient than this, and this is what we want to tackle as an innovating company. However, it's not only about this macro trend of creating this digital twin or digital information of the underground. There's also during the construction process in itself where we need to take often many decisions on site. Just as an example, if there's a trenching machine and you need to know if it is safe to trench here, or if there might be a fiber cable that you would cut and leave half of the city without internet. These kind of decisions need to be taken on site. So these two different angles are what inspires us to develop the GS9000, which is a multi-channel ground penetrating radar system. When we say multi-channel ground penetrating radar, we are talking a machine that is technologically very advanced, that in practice works as many ground penetrating radars working in parallel. And what we aim for as a solution supplier or manufacturer, in the end, it's to provide our clients, actually the end users of such a system, with the maximum accuracy, maximum versatility, and maximum simplicity as the way to be more efficient. So first of all, when we are talking about GS9000, there's of course a sensor, there's of course the hardware itself, but we talk about the system. There's more pieces to it. So first of all, this the sensor is connected with a field app that that can do actually a big part of the work that until now had to be done only in the office because there was no other choice. Actually, with this field app connected wireless or wired to the sensor, you can do a lot. And additionally to that, for advanced analysis, advanced use cases, there is post-processing software and cloud services that come alongside. So when we are talking about GS9000, we are really talking about this complete system comprised of multiple components, hardware and software. So let's start just a quick overview on the hardware, on the sensor. So first of all, you can see already in the images, I'd say, a nicely designed instrument with some guiding principles in terms of design that I would like to quickly share with you. On one side, we have focused a lot in providing excellent ergonomics in terms of being able to move the system around, rotate, like bend, fold it, transport it, and made it at the same time very lightweight and durable, which is something that we attain by utilizing carbon fiber as one of the main materials. And this is pretty unique for this kind of product line. The GS9000 comes with integrated electronics and integrated geopositioning. So these things, in the end, you don't need to be very much worried about them, are part of the system. The electronics are part of the body of the card itself, the geopositioning, instead of having to go to a third-party solution and let's see how it connects with my GPR. In our case, we really provide it as part of the package. It's wireless. The system can also be wired in case there's Wi-Fi restrictions. And it is powered by simple power banks, which means you can attain a full day, power supply easily with just 2 hot swappable power banks like the ones that we supply. And if in case you need to add more, you just need to go to an electronic shop and get it. And last but not least, there's 2 guiding principles that contribute a lot into this maneuverability, which is something we were looking for very carefully. It's on one side, the system has a minimal footprint. So the distance from front to back wheel is very, very short compared to, all the multi-channel systems, which makes much easier to curve, to bend, to change the direction. And at the same time, we aimed for maximizing the data swath so that in one go, you can collect as many data as possible. And yeah, this is a Swiss-made quality. So this system is produced in Switzerland with the highest build quality standards. As I mentioned at the beginning, we are looking for an equation that says versatility plus accuracy plus simplicity equals efficiency. When we're talking about versatility and accuracy, we're essentially talking about the sensor. And in this case, it translates as 2 interchangeable arrays for a vast array of applications. This is one of the traditional limitations of such systems in the sense that they were designed for one specific application. What we designed is a system that can accommodate either a GX1 array, which is designed for structural diagnostics, such as analysis of bridge condition deterioration, or concrete cover and moisture mapping, asphalt layer thickness analysis, or even in utility mapping and detection projects when we're talking about very small, shallow utilities, such as fiber cable, or a GX2 array, which is mainly designed for geophysical applications such as subsurface utility mapping, underground cavity detection, archaeological prospections, or UXO surveys. So the system can be furnished with the GX1, with the GX2, or with both. And you can just interchange them in a matter of 1 to 2 minutes very easily. Let's first have a look into the GX2 array module, which, as I mentioned, is designed for geophysical applications. So we're talking first 2-3 meters, depending on the location and soil conditions. This is based on step frequency GPR, which is the flagship technology from Screen & Eagle that has been incorporated already into product lines such as the GP8000 to gs9000. In this case, we're talking a modulation range between 30 and 750 megahertz. As you can recognize, this is quite a wide bandwidth. There's 11 parallel channels with a spacing of 7.5 centimeters or 3 inches, producing an effective swath of more than 80 centimeters. Now, if you think of this is the 11 parallel lines that get scanned longitudinally. Now, if you think of how many traces a line can contain, you can actually measure up to a less than half of an inch, or like 0.4 inches, and then that will produce a very dense matrix of information. So essentially, in every single intersection, you would get a scan or trace. If we look at the GX1, this is even more impressive. GX1, which is designed for structural applications, so essentially we are talking under a meter of depth. Same technology, step frequency GPR with a higher modulation range from 500 to 3000 megahertz. Here we have 2 polarizations of channels, 35 in VV and 15 in HH configuration, with a channel spacing of just 2.5 centimeters or 1 inch, which is essentially 3 times more density than the previous status quo in the industry. So it produces a very, very dense array of information. If we cross it with a very, very dense scanning, and you add the 2 polarizations, just to give you a figure, this translates as 5,000 A scans, 5,000 traces per linear meter that you scan. And all of this information, as you will see now, is processed, plotted, and visualized in real time. So we have the ability to process all that information just on the fly, which makes it a unique product in the industry. So I mentioned before, like 2.5 centimeter spacing is 3 times more dense than the previous standard in the industry. And this is just to illustrate, on a roadway, this is what you would get with the GX1 if we only had a spacing of 7.5 or 3 inches. If we had 3 inches, this is how the image would look like, which, hey, it's a good resolution for a tomography from the top. However, the real capacity of the GX1 is to produce an image like this, where you can even see the cracks on the asphalt, in this case, like 5 centimeters, or let's say 1.5 inches below the asphalt. You could see this cracking situation in this deteriorated road. And this is just a matter of the density of the information in the XY direction. So this is what makes our system really so versatile in terms of sensoric or sensor technology. There is an extra level of versatility because, as I mentioned, these arrays, GX1 and GX2, can actually also be interchanged with our GM8000, which is the vehicle-mounted mobile mapping system. In this case, you would mount 2 of such arrays in parallel, and they can be run at high speed on a vehicle, and map larger areas as well. So this is an extra level of versatility that we also aimed for when designing the GS9000. Good. So this is kind of a summary, GS9000 with all certifications, FCC, CE, UKCA. It's just 45 kilograms, so it's relatively lightweight, but actually because of its shape, it's very maneuverable with those two array modules that it can be connected with, wireless with the optionality to wire it, batteries, which are power banks, therefore it's also flight safe, up to 100 scans per linear meter, and all paired with real-time 3D accuracy coming from a GNSS receiver to provide between 1 and 5 centimeters, depending on what service is in use, whether it's SSR, which is included in our system for certain regions in the world, or N-Trip if you have your local server available in the area. Just need to connect over internet, and that's it. So this is regarding the sensors. However, there was a third element to the equation, which is this simplicity as an enabler for being more efficient. And here we are talking mainly about software. We are mainly talking about what my field app can actually bring me by the fact that it provides me with 100% live data visualization. What is the main consequence of live data? Live data, if properly visualized, intuitively visualized, actually helps reduce guesswork, which is one of the traditional pain points in GPR. In GPR, as the most experienced users will know, this is the traditional view of GPR, where you have just a massive amount of elements that appear in a black and white radargram, which are not that easy to interpret. Sometimes with a little bit of exposure and education, you can really get to a good level. However, you are still only looking at the side view. You are only looking at the 2D image of a longitudinal section. With GS9000, first of all, this is translated into a dual view. Okay, all these radargrams can be plotted together in a view from the top, in a planimetric view, as we would see on the upper side of the image. So here you can see this is the channel 2 marked in yellow with a yellow line on top. There's the channel 4, which is marked with a yellow line. There's the channel 6, which is marked with another yellow line in the middle. And this actually reconstructs a tomography as you would see from the top. In this case, what I'm showing is, okay, show me everything in a certain depth range. That's that slider that you can see on the left-hand side, which says from 077 to 104. So in that section of my scan, I actually hit 1, 2, 3, 4, 5, 6, 7 utility lines in different angles. But I can only prove that because I'm seeing the image on the top. From the radargram, would I be able to see that reality? Well, probably not. And there's an additional level to this, which is when we add georeferencing. So when precisely georeference, actually those swaths or those super lines, let's say those reconstructions of the multiple radiograms can be also put in a absolute 3D environment. And that actually gives us the real locations of the different elements. In this case, you can see a street crossing where, like from just 10 scans, 11 scans, you can get it fully mapped. In this case, showing what happens between 077 and 104, but I could also extend my slice and go shallower and deeper and show me everything that appears in that space. So this is how we presented information in our solutions. And just to give you a quick idea, I will run a short video. This is what you would see if you have a GS9000. I think the video is a little bit slow. You can mark as you find the new elements. And then with a single swipe, you can just jump into a fully georeference view and actually see both the raw information and the findings in a 3D environment overlapping a satellite image. So in that case, it's actually very easy and very intuitive to say, hey, this line goes from here to there. This is my drainage line or my gas and oil line. And this one, is a different line, electricity or whatever. And you have all these traditional CAD tools actually integrated in the solution so that you can just simply export it to the XF, to KML, to shapefile out from the field, directly from the field. And so this is how we simplify the process of detecting and mapping utilities. As I mentioned before, there's the non-georeference view called Superline, comprised of this top view and lateral view, when the focus is on locating what lies just beneath. I get the tomography from above, the tomography or the radargram from the side, but no 3D positioning on a map. Or I can choose to connect my GPS, and in this case, what I'm using is the so-called free path methodology that we incorporated already in the GS8000 line, but it's much more powerful with the multi-channel system GS9000 when the focus is on capturing the subsurface reality on a 3D map. So the same story, it's live tomographic view, live radargram, but everything absolutely positioned 3D on a map in the coordinate systems of choice. So we have the full EPSG library is also loaded in the system, preloaded. So you can just check. Let's say I'm in the WAM island. So let's see what coordinate system applies to WAM island. And because this is, based on iPad technology, this is controlled with very simple gestures. So probably in a matter of a few minutes, you're already mastering the software. Changing views is to swipe with 2 fingers. Zooming in and out is also it's a gesture with 2 fingers. Moving back and forth is a gesture with 1 finger. Very easy to move from one to the other. Additionally to this, and we have incorporated something very interesting, which is the dynamic gain. So this is essentially what allows me to show very thick slices, going from very shallow to very deep, and actually show the different objects that appear at different depths. This is thanks to the so-called dynamic gain that we developed for the GS9000. However, you can always deactivate the dynamic gain if you're looking for something particular. Let's say I want to keep the dynamic gain in the tomography, but I want to just play with the gains myself in the radargram. So you can deactivate and use a manual gains, linear and time gain compensation. And of course, the system comes with some filters like noise cancellation, background removal, etc. Frequency filter. There's something quite interesting, which is the 3 values that you can see on the bottom, which are the normalization, sensitivity, and the ability to toggle on or off the Hilbert migration. So normalization and sensitivity have to do with how nicely this tomography is shown. So let's imagine the following scenario. Let's imagine that you are scanning with a color palette that goes from blue to red, when the red corresponds to the maximum peak of signal. However, now you hit a manhole. Manhole is a very strong peak of reflection, which happens just on the surface. So if the red color is assigned to a manhole, then essentially any utility that might be below will just be too pale in the blue side of the color scale. So with sensitivity and normalization, what I can do is essentially eliminate those corner situations. So, okay, I hit a manhole, perfect, that's no problem because that gets ignored. This peak of signal gets automatically ignored. And additionally, the Hilbert migration. So this was a feedback coming from many customers. Many people like to see the migrated view with thick slices. However, sometimes you can extract more information from a raw, from tomography out of the raw information at a very specific depth. So in that case, you can just toggle off and you can just move at different depths, and see the details on the raw data. So all of these functions are actually in our field app. So you don't really need to go to the office to essentially to have a view on both and compare to each other. Right? You can do a lot of interpretation directly on site. And obviously you can also trace your lines, do essentially your line work, and export these to, as mentioned, CAD or GIS formats in just a click, right? That can be sent over email or over chat, whatever you want, to a colleague that could be anywhere in the world. So to summarize, in the end, the traditional workflow, especially in utility mapping, has been traditionally very fragmented, with a first very long preparation time, setting up grids or doing long explorations, then the scanning, which is semi-blind, just looking at radargrams. So you need to use a lot of like experience in the end just to be able to make the correct interpretation, typically placing marks on the ground so that then a survey crew comes with a GPS in a separate step, and hopefully they can interpret the marks that you made in the field. Then when all of that information is collected, it's brought typically on a USB stick, sent to the office so that somebody can consolidate all of the information and only eventually be able to analyze. So there's a lot of time, uncertainty, money, and a big hassle involved in all this workflow. How we see it at Screen Eagle in the end is that there's a way to streamline this workflow with just bringing much more functionality to the field with powerful processing or live processing. So scanning and mapping becomes one step where you digitize all the findings on the map on the fly. The results are visualized on the fly, and the data are synchronized to the cloud, so that if somebody, which could be you, yourself, or somebody else in any remote location, can actually do advanced analysis or post-processing on those data directly over the web. But there's many applications that go beyond utility mapping or traditional geophysical applications. These have traditionally not been addressed by many products in the market, not to say probably none. And for us, it was the opportunity to bring a technology that was already proven in our concrete lines, in our gs9000, into the context of a multi-channel system working at high frequencies with the GX1 array module. So in that case, my app is the same, just the app can control many more data, much more information, as I mentioned before, up to 35 plus 15, so a total 50 channels of information, where I can really look at the detail in the very shallow space. Like, for example, in this case, you can really see two different layers of rebar, can visualize them, of course, also not migrated, to have more insights into the information. And all of this is exactly the same as in the previous case, 100% live. So as you move, really the app is going to bring all this information without any delay. I mean, being able to visualize the different depth levels just with very simple gestures on an iPad, and essentially getting the same functionality that you could get with a GX2, you can also get it with a GX1. And this is pretty much a game changer in the industry. Just to give you two examples, on the left-hand side, you can see a real scan of it's on an airfield. You can see there's rebar layers or reinforced concrete, plus a utility line that is really hitting transversely. And I think there's a little bit of lag in the video, but I hope you can really see it. Here we're going to hit a utility line, as well as scanning the complete reinforced slab. And on the right side, you can actually see a different case. This was quite interesting, and this is just to showcase that sometimes what you see is not the objects directly, but indirectly. So here, what you can see is, okay, there's what seems to be a clear line going from top to bottom in blue color, which blue color means actually absence of a signal, and that's because that's a trench. So sometimes you can get many more insights into the data from what you cannot see if you can actually see that in the tomography. So all of this, as I mentioned before, gets synchronized to the cloud. This is thanks to the Workspace platform. So everything is powered by Workspace, which is cloud-connected workflow and services, so that you just collect, sync, and share your information. This is a platform that you can access directly over the web. And thanks to all of this, ecosystem or all this platform, in the end, we have the different tools that are needed in order to attain or in order to tackle very different applications in the ground penetrating radar world. So all the way from shallow and very high resolution applications such as airfield investigations, structural inspection, roadway investigations, or bridge diagnostics, which require a lot of data in the first meter or even less, and can be comfortably addressed with the GX1, all the way to safe digging, utility mapping, subsurface utility engineering practices, as well as geophysical or archaeology forensics, which is in the traditional space that would be addressed with a GX2. And just to illustrate this, I just chose a few images on how it looks like when your data are synchronized to the cloud. So here you can see, a case of utility mapping. So here you can see 4 different concurrent users from 4 different locations looking at the same project, where the CAT, existing as-built CAT information is overlaid with the as-is information observed with the ground penetrating radar. So there you can really easily, correct your CAD information with up-to-date evidence as observed in the field. Obviously, all of this is georeferenced and with all the output formats that would be desired. So this is utility mapping, which is probably the most well-known application for ground penetrating radar. This is an example, now an example of archaeology. So this is a site prospection, where actually multi-channel combined with live visualization provides a big advantage. So for those of you that have ever been in archaeological sites, often what you know is, look, there must be something around that area, but that area might be quite extensive, quite big. With a system that provides you with a real-time visualization on a map, you can actually see or start exploring, and you will immediately identify, oh, this is the area where actually there is something. That provides this initial exploration experience becomes much easier. And then instead of losing a complete day just trying to blindly find where that exact site was buried, you can go much faster because you don't need to send any data to the office to process it. This is quite an emerging application as well. What you can see here, it's very different to the previous case. Like, what is this? So this is tree roots. So of course, often these tree roots, as you may know, are related to problems in road tarmac surface that gets cracks and so on. Sometimes there's, for environmental reasons, that this information is useful. So with ground penetrating radar, you can actually get quite a good view of how trees propagate below ground, because there are reflections that, when put in a absolute spatial context, they make a lot of sense. This is another interesting application for a GX2. In this case, this is leak detection. So what you can see here is that something showed up very clearly in the tomography. There's an area where there's something happening, and actually by cross-checking the tomography with the radiogram and with the reconstructed transversal radiogram, which is what you can see on the top, which is nothing else but plotting all those 11 channels transversally, not longitudinally. So you can really confirm that here there is an area where there's a water leak. There's a lot of things ongoing down there. So let me move to the next image. In this case, now we are going to look at GX1. So now we are talking high frequency applications. This is the image I showed before about that road. So this is essentially inspecting the status of asphalt. I mean, here we are in the first centimeters from the surface, but already these cracks are showing in all its detail. So, I mean, maintenance of roads, this is very valuable information. This is in an airfield, and here what we are seeing is very, very clearly what is the different layers of material. So we can see the tarmac surface, then polycompacted earth. There's additional layers of other materials. Whenever there is a change in material, there's this very clearly defined contrast. Actually, in the center, you can see that there was probably some sort of cavity. So you can really make an extensive analysis of what's below just from moving the GS9000 around. Just staying in the same environment, so you can really reconstruct structural information very, very thoroughly. So here you can say, what's below a tarmac or asphalt surface with different elements showing at different depths. So here you can see a utility line. Now rebar starts appearing, the first layer of reinforcement that propagates through the entire location, and you can see how there's also this correspondence in the radiogram below. It just propagates, and then you get additional layer changes or anomalies that you can really spot in different regions. So in order to get very, very accurate and comprehensive views of structural elements, the GX1 is a fantastic tool. Of course, this information could also be visualized in a migrated way, which probably would be more understandable. You can see really the level of detail at different depths. And just continuing in that space of structures. I mean, there's one particular structure where the GS9000 is already providing many tools, even automated tools that can help you have a very comprehensive understanding of that element, of that structural object, which is bridges. For bridge deck analysis, ground penetrating radar is a fantastic tool that can provide a lot of information. Often the problem is how to interpret and process that information. So here, what we bring in is the power of automatic detection through cloud computing. So through automatic detection, every single hyperbolic reflection in this case could be digitized, and then based on that we can really analyze what went through that specific scan or signal or trace, so that not only the map of the actual reinforcement is there, but we can produce things like deterioration and condition maps according to standards such as the ones defined by ASTM, where we can really see, okay, there's a risk of deterioration here, there's some anomaly showing up in this other area. Moisture maps, in this case, this bridge, it was pretty homogeneous, but you can definitely make a quantitative analysis of the moisture content, or even qualitative, sorry, and then quantitative analysis such as concrete cover maps, which, as many of you will know, are essentially related to the status of a concrete structure. So all of these tools are part of the post-processing solution, and they're available as part of the GS9000 package as well for those of you that might need to make these advanced uses. So with this, I pretty much try to cover a little bit what makes the GS9000 essentially a ground penetrating radar as easy as you could ever dream of, and even covered partially some of the applications that you can tackle, that you can address with this system. So now I leave it up to David in case, we're going to run a questions and answer session now. So
yes, thanks, David. And thanks for the presentation. Hopefully everyone found that interesting, and hopefully it really came across how Screen Eagle are really sort of looking at the market, how it currently works, and pushing the boundaries in terms of both technology and software to really get the best user experience of all of our products. So thank you for that. I am just going to start another poll question. So if you guys can answer that as well, and also send in all of your questions. We've had quite a few come in already. If we don't have time to answer all of them today, we will answer every single question, and we'll send it out to everybody so everyone can see the responses as well. Okay, so the first question is what are the benefits of using step frequency?
Right. Okay, that's a good question. So on one side, I'm asked this very often. Like, Screen Eagle ProSec is known for having incorporated the step frequency technology into this kind of handheld or hand pushed systems, and the simple answer would be it's a matter of bandwidth and data quality. So first of all, with step frequency, correctly modulated step frequency, one must say, you can really attain very wide bandwidths with a very good, dynamic range, which for those of you familiar with the technical terminology, speak for data quality. In the particular context of multi-channel, there is additionally two benefits that stem from that fact, which have to do with having all channels producing a balanced image. I mean, if you have used pulsed radar in a multi-channel system, you would know that sometimes the time zero is not consistent between all channels or between different devices, indeed, and the same applies to the gains, that the gains may also not be exactly homogeneous, which obviously affects the images that get produced. I can see a very clearly defined reflection in this channel, but not in the next one. Or actually, there's a small offset between this one in the channel 1 and the channel 2, and actually should be the same. That's confusing. So because step frequency works in the frequency domain, in the end, these problems, I mean, it doesn't get affected by these problems. So essentially, the time zero is consistent across all channels. The gains are also very consistent across all channels. That's more like the technical side of it. And additionally to this, it is really high frequency applications. I mean, as I mentioned before, there's not many products in the market that can really work at very high resolutions with a multi-channel system, right? This is pretty novel, and that is thanks to step frequency to a large extent, right? That step frequency is the technology for providing this high resolution imaging on a multi-channel system. I hope this answered the question. This can go quite technical, but I mean, I try to keep it as digestible as possible.
No, perfect. Another question, can the equipment be paired with a robotic total station instead of the GPS to be used in where GPS signal is not available, like under?
So that's something that, I mean, for those of you that know our gs9000 know that the gs8000 since some time we are able to pair it with a robotic total station from virtually any brand. With gs9000, it will be probably something in the next software version. I mean, that's coming as well, which obviously will bring additional versatility for usage indoors.
Perfect. I've had a few questions about that, so thank you. Quite a few questions on cost as well. We can send those across. And there was a question here as well about security and theft of the system. How do we compete against that? Maybe I can answer that one. So the way the system actually works is we have the hardware, and then we have a license attached to that hardware. So if in the scenario where the equipment is stolen, we can switch that hardware off. So the only way they can come and reactivate that is by speaking to us directly. So you have protection there against that. So the system essentially becomes a paperweight. We're the only ones that can switch that on, and obviously we have your details to make sure that that equipment wasn't taken and was sold or anything like that. So hopefully that answers that question. The other one is to do with speed of data capture. So how quick can we capture data with either the GX1 or GX2?
So speed of data capture, I mean, like in the end, I mean, this is a push card, and it's strongly correlated with essentially your settings. So you can set the system. I mean, in standard mode, you can go kind of running. So it will be something like 7 kilometers per hour or something like that. That's the standard mode. But you can go in both directions. You can tell the system, look, I want to add more averaging. I want to add more average into the signal. And for that, I will need to go a little bit slower, like walking speed, 4 kilometers per hour or something like that. Then you set your system to max speed. Or I mounted it on a quad. I mean, I'm okay with getting a little bit less, averaging. But I want to go faster. Then you set the system to work in max speed. So the system has 3 modes. So essentially walking, running, or, let's say at a slow vehicle kind of configuration. Of course, if you want to go like faster and faster than the product, for that would be the GM8000, which is the vehicle mounted version.
Perfect. Another question related to the tablet of choice. Why do we use iPad?
So, I mean, actually, this is it's a good question. I mean, iPad. I mean, I would actually say an iPad Pro, and I mean, the answer to this is very much given by what you could see in the presentation. Like as you can imagine, in order to process all that information live and plot it and visualize it on the fly, you need a lot of processing power and a lot of, I mean, a very, very, very powerful graphical capacity. And today in the market, there is only one. There's only one tablet that can provide that, and that's the iPad Pro. And here I would actually say they because we design our products with long-term view to bring more and more features and functionalities. I mean, the iPads also grow at that same speed. So just to give you an idea, I mean, just from the 2021 iPad Pro to the 2022 version, there was a 45% of processing power increase. And from the 2022 to the 2024 that was recently launched with the M4 chip, there's an additional 25% of processing power increase. So essentially, the tablet has also been growing at the same speed as our solutions, right? And for us, this is really a strategic decision based on that we value most, which is the user experience that we want to bring to the field user. So that's it. And just on the iPad, the question also came this morning. So actually, the iPad can be connected wireless, but can also be connected by cable to the GS9000. And if you connect by cable, actually, it can be powered from the GS9000.
Perfect. There was another question on the iPad as well, which I'll answer, which is how well does it work with sort of rainy conditions? So it's still a touchpad screen, so obviously rain doesn't like it too much. However, we do supply the system with a rain and sun visor on the system to keep it protected against the rain. But there is other accessories we could buy, like an umbrella holder, if that was something in the conditions that you're facing all the time. So there is different options, including cases as well, that you can have, which stop all these problems. So we don't really see that many issues out in the field, even in rainy conditions. I'm based in the UK as well, so we cool. So one last question, Gorka, and then because there's quite a lot here, so we'll just do one last one, and then we can answer the others manually afterwards, and then send them out to everybody. So, why did we choose only double polarization with the shallow antenna with the GX1?
So yeah, that's a good question, and obviously there's a lot of investigation and testing behind, right? So for the high resolution, high frequency antenna, that was a no-brainer. That was a no-brainer because often you're looking for shallow objects. You need a very high resolution, but those shallow objects can be really perpendicular, parallel in any direction, such as a reinforcement in concrete. However, when you look at it at a deeper space, you need to take into account things like the resolution of your image because of the frequencies. You need to take into account the channel spacing. And in the end, you need to take into account what the consequence would be of adding another set of antennas. The consequence would be very, very simple. The antenna would need to be way bigger and heavier. So, essentially, the benefits of a second polarization in a low frequency antenna are quite negligible in reality. Because with a reconstruction in the office, you can actually get much better insights. The things that you would miss them the same, and the things that you could see most likely with an antenna spacing of 7.5 centimeters, you could also see them even if running parallel. And essentially, in that trade-off, it became a no-brainer also quite early on. Like. The implications in size and weight do not get compensated by any tangible benefits in terms of detection or in terms of mapping. So that's a reason why we have two identical modules from the outside: the GX1 that has two sets of antennas in two polarizations for the shallow space, and a GX2 that has 11 antennas or 11 channels in one polarization for deeper objects. And that would be it. Mm-hmm.
But sorry, there's one question that came in. You did answer it, but it's a good one. So, can I migrate data from old iPad to new iPad?
Mm-hmm. Yeah, so that's absolutely no problem. So essentially, which iPad you use is completely relevant. In the end, what you do is you log in with your user credentials, and the data are assigned to your personal space, to your personal ID. So if you change your iPad, and you log in with your ID, then your data from your ID would get loaded immediately, and data would be always safely stored in your personal cloud space. I hope that answers it.
Yes, perfect. So it was just a quick one. I know I said the previous one was the last one, but there's quite a lot of questions still coming in. So what we'll do is we'll take all these questions offline and we'll answer them all and send all of the answers, both from this webinar and the one from this morning, to everybody. So you can see all of the questions answered. One of the other questions that came in was regarding to the webinar being available for people to view. Yes, the webinar is recorded, so we can send these out, the link out to everybody so they can view it at a later point if you want to as well. So thank you, Gorka, for the presentation, and thank you to everyone. And have a good evening and rest of your day. Thank you.
Thank you, everybody. Have a nice day. Bye-bye.